Today we will see the same problem but with different approach. Yesterday, yesterday we solved this problem with the iterative approach. Today we will see recursion. So let's start with complexity analysis. Here, yesterday what we saw that the range was very much less, due to which what happened was that a recursive solution is also working in this case, because if range is larger, then in that case recursive solution will not work. It will slow Stack Overflow exchange. Okay. So yesterday what we saw that we solved this problem with iterative approach. And what is the problem with recursion that I've told you already? Okay. So this since this question is having a lower range, so this question is solely meant to solve with recursion. Okay. And here what happened was that we solved this problem yesterday uh, with iteration, and in that method we created a dummy node. And no, you know what? The creation of dummy node in that case occupied much more space than the the algorithm which is working behind recursive method. So in this question, for this question solely, the iterative approach was quite better than recursive approach. Quite better, not much better, but very much less difference is there. Okay. So let's see today with recursive approach, and then since you see the range is very much less, this question is solely meant for recursive, and then let's start with that. Okay. So let's move on to paint. So okay, fine. So we'll see recursion. Okay. So what was the question? Let's see. Let's take any one test case so that you may understand better. 1, 2, 4, and 1, 3, 4. Okay. So we have 1, 2, 4, and then 1, 3, 4. 1, 3, 4. Okay. So in recursion, what we do, we call method inside a method itself, and we repeat until anyone becomes null. Okay. Just listen, everything will be clear. Okay. So initially, list one pointer was pointing to the first node, and list2 pointer was pointing to the second node. In that case, and in that case, you know what? We are just comparing. Uh, Suppose if list1 is less than list2, then we will call the method. Yeah, what we did in iterative approach, we just connected the pointers. But in this case, if a node is smaller than the other node, then what we do is we usually call another method, sorry, the same method, but with updated parameters. For example, if list1 is less than list2, then we will call the same method, but with updated parameters. And in that parameter, we will point the next node to that node which is smaller. Okay. Suppose if list1 is less than list2, then we will call the method, and then in that method we will give the parameter list1 dot next and the same list2. Okay. If in this case, if in other case, if list2 is smaller than list1, then we will call the method with updated parameters having parameters list2 dot next and list1. So what will happen in that case? Let's see. For example, in this case, list1 is not smaller than list2, then else block will get executed. And in the else block, what is that? We are pointing list2 dot next. Initially, list2 is 1, so list2 dot next is equal to method call, and in that method there will be updated parameter 1 comma 3. Okay, why 3? Because the one which is smaller, since it is not smaller, but it is in the else block. Why else block? Because it is not, because list1 is not smaller than list2. So list2 will get updated to list. So 3, it will point to 3. Okay, this is null. Should point it at null. Okay. So method call is 1 comma 3, and then what we are doing, we are actually returning. Sorry, we are actually returning the smaller one, which is actually list2. So return what? Return list2. Okay, that is 3. Okay. Now what is happening in this method? We are calling the same method with updated parameter 1 and 3. Now list1 is 1 and list2 is 3. Which one is small? List1, then list1 dot next is equal to method call with updated parameter. Now list1 will point to 2 and list2 will remain at least at 3. Okay, then 2 comma 3 is the new parameter, and then what you are returning, actually we are returning list1. What is list1? 2. Okay, now what is happening inside this method call 2 comma 3? So which one is smaller? 2 is smaller, then 2 dot next is equal to um, what? 2 dot next is equal to, we will check. Okay, which one is smaller? 2 is smaller. Okay, and 3 is bigger. So 2 dot next is equal to updated parameter. List1 will point to 4. Here we will see method call with 4 and 3. And what you are returning in this case, the same list1 actually, which was smaller. Okay, now see, updated parameter is 4 and 3, but this time list1 is greater than list2, so else block get executed. And what is inside the else block? List2 dot next. This time we are doing 3 dot next is equal to method call with updated parameters. So list1 will reveal same, and list2 will point to the next node. So list2 got cancelled and list2 is here. What is list2? 4, 4 and 4 it will be here. Okay, and then we are returning list2, actually 4. Okay, so okay, so let's compare which one is smaller. No one is smaller. Okay, but as no one is smaller, both are equal, so else block get executed, and in else block we are dealing with list2. Okay, then list2 dot next, that means 4 dot next is equal to updated parameter, method call updated parameter. This full will remain same, and then you know what, one thing you should remember, that this 4 is this one, list2 one. Okay, and this 4 is this one. Okay, so updated parameter, so list2 will point to the next node, which is null. So that's where we are ending the case. And then what is happening here? If anyone is null, if anyone, for example, if list1 is null, then return list2. If list2 is null, then return list1. So what this method is returning? What this method is returning? If list2 is null, then return list1. What is list1? List1 is pointing to 4. So it will return 4, and along with null will also come because they both are linked. Okay. So what will come here? 4 and then cross. Okay. Now, this was the whole recursive algorithm which was working behind the computer, and then it will move backward. Okay, let's let's move backward. Okay, now this 4 is pointing to that node. Okay, this is which this method is returning. What this method is returning? 4 dot next. So just put here 4 dot next, and then it is connected to 4. This 4. Okay, this 4. Now 3 is connected to some that node which is returned by this method call. So 3 dot next is 4. Now what is 4? This actually. Okay, this 4 and this 4 are actually same. So 3 dot next is this one. Now 2 dot next. 2 is pointing to that node which is returned by this method. What is returned by this method? Actually 3. Okay. Why? Because 3 is smaller than 4. So we are returning that one. I have returned it by mistake. Okay, so we are returning that node which is smaller. Here also we are doing the same thing. Then we are returning 2 here. Okay, because 2 is smaller than 3, and then here also we need to change. It will return 1. Why? Because 1 is smaller than 3, then return 1. If 2 is smaller than 3, return 2. That means if this is actually list 1. Okay, list 1 and list 2. We are returning list 1 and list 2. Okay, list 1 is less than list 3, list 2, then return list 1. If list 2 is less than list 1, then return list 2. Okay, this is list 2. Similarly, we are doing, if list 1 is not less than, you know, if list 1 is less than list 2, then return list 1, else return list 2. So this is list 2, then list 2. Same thing. So 2 is pointing to 3. That means this list 2. Okay, and then similarly 1 is pointing to the node which is returned by this method, and here to list 1. So list 1 is already connected with this much node, so it is getting updated. And then what this one is pointing to, this one is pointing to the one which is returned by this one. What is returned by this one? Actually 1. So just connect 1 with 1. Okay, and then this is your you know, the desired linker list. Now what we're going to do is here, so first of all, what is required? Nothing is required. Actually, everything is created. What the best thing about recursive algorithm is that you are not required to create any link, any node. Okay, and that's the place where memory is saving. And if whenever you get less range, then go with recursive one, because in that case you are not necessarily creating a node. Okay, so let's just start a condition. If suppose uh, I'm giving condition list1 is not equal to null, and list2 is also not equal to, so it is moving in such a way. Now if again list1 dot val is less than list2 dot val, then you know what, sorry, then you know what, I will write list1 dot next is equal to what, method call. Okay, and it is smaller or what. Okay, merge list and with updated parameter, then which one will point to the next node, the one which is smaller, list1. So list1 dot next comma list2, it will remain as it is. And remember what we are returning, we are returning the smaller one, so return what, tell return list1, because list1 is smaller in this case. Similarly, just write here else block and then copy paste type of, okay, only this one, here we'll see, and then actually something here, paste, and then just do it list2 dot next equal to merge to list1 will remain same, and list2 will point to the next node. Why? Because it is smaller. List2 dot next and then return list2. Okay, and now we'll just check for condition. When the flow of control will come out of this loop, this if statement, if any one will become null. So let's suppose if list1 is null. Okay, then what I want to do in this case, return list2 simple, else, sorry, return list1, done. Okay, let's check it in for let's check for any kind of typo or something which we have done. Let's see. So error is that, okay, cannot find the symbol. Okay, it is MER. I have written me. Okay, R merge to list. Okay, L, what is, cannot find the symbol, merge list. Okay, where is that? Yeah, this one, list 1 and comma list2 dot next. Okay, let's run again. Okay, oh shit, the same way, because we had copy pasted, no? So MERG merge to list. Okay, it is type. Okay. One more LSIT. Okay, typo. List 1, return list 1, otherwise list 2. Okay, done. Beautiful. That's submitted. So here you see time. There is no any question about time. If you compare both iterative and recursive solution, the quest is about memory. See, this time we have much more good memory. Let's see all the submissions. So yesterday we saw this one, this iterative solution, which was, oh my god, today they are showing equal, but yesterday the memory usage was different. So let's blame Leetcode for this, and then we will continue with next question. Okay, and then I will discontinue for today.